Alright, hello. Welcome to this new episode of Life Coding with the B team. Welcome to this new episode. This is episode 25. Alright, I have some background noise. Alright, let me know if you can hear me well. Sorry for the delay, we had to change the YouTube key. Let me know in the chat if everything is fine. Alright, yeah, there appears to be like a 30-second delay between what I'm saying and when you actually hear it, so alright, let's do this. I selected a few issues for today, so that's what you can see in progress there. So we have start using new parents type, we have requested milestone 0 message ID not present in the Tango, we have a node tool to convert between eggs and bag32, and we have check API permission after endpoint. These are all quite small issues and they shouldn't take too long, so I think we can manage to do all of them in 1 hour, but I have a tendency of speaking too much, so let's see what we can do, and please feel free to ask any question if you have. I'll have some tea now. Alright, so the reason I chose this one, check API permission after endpoint, is basically to present the API, the REST API of the B node, because I think it's nicely done and it showcases a lot of Rust. So I think it's a nice thing to see. Alright, let's see what it looks like. Alright, so this is the REST API of the B node, and you can see basically we have one function per endpoint, and you can see how an endpoint is done. Let's take one that is easy to understand for now. Alright, let's take this one. So this is the API method to get a specific message by its ID. So let's see how it's constructed. First thing we do is to check if we have permission to do that. We have permission to do that if we are asking for an allowed IP. So it could be localhost or it could be any IP that has been allowed in the configuration file. If you go to the configuration file, it looks like something like this. So you have a set of public routes. Public routes are always allowed, so anyone can access these routes. And you have a set of allowed IPs that have access to all APIs. So for example, in the public routes, you see that there is no routes regarding peers, because that's not something you want to publicly expose. But if that's something you want to do, you can obviously add it there. So it's done in 2 times. There is a set of public routes that anyone can have access, and then there is a set of allowed IPs that have access to public and private routes. So this is what this line does, it checks for permission. And then you can see that there is this operator AND, which is going to combine. So you are going to do a combination of many things. So the first thing is that we need to have permission. Then it needs to be a GET. You know that with REST APIs, we have different verbs in the HTTP format. So we have GET, POST, DELETE, that kind of things. So we need to have GET. Then we are doing another AND, and we want the path to start with API. Then we want the path to follow with V1, then we want the path to follow with messages, and then we want, in the URL, we want to have a message ID. And that's the ID of the message we want to get. and then we want the URL to stop. We want that the end of the URL is actually the message ID. And then we want to pass a handle to the Tango to the method that is going to handle this endpoint, and the method that is going to handle this endpoint is this one. So basically, you are just constructing the way the URL should look like. So if we go to alright, let's have a look at the REST API. Alright, and basically the URL we just constructed is this one, API v1 messages message ID. So that's how we construct one URL, and then when we have them all, basically what we do is that we combine them with an OR operator. So when you have an incoming API request, it's going to try all of them until it finds something that matches. So is it a else API call? No. Is it this one? No. Is it this one? Until it finds something that matches. Alright, so I was doing the dashboard authentication today, and I noticed that in these kind of methods, the first thing we do is the permission check. And I wondered if that was a nice thing to do. Basically, what this as permission does is it's going to copy these two things. I have massive background noise. Yeah, sorry about that. I have my headset, so I'm not sure I can reduce it down. Alright, let me try something. Alright, you'll tell me if it's better. You should hear me lower, but maybe a little bit more background noise. Anyway, so this as permission stuff is doing a copy of the public routes and a copy of the allowed IPs. And then inside of the method, if we go to the definition, as permission, where is this? What it does is that it's going to check, it's going to do a contain in this one and a contain in this one. So this is two hash map access. Hash map access are obviously fast, but there is still a hash involved. So we are doing two clones and we are doing two checks, two contains. But what's doing there is not the way end works, is that you are not continuing the execution if something before failed. So we want things that fail, we want things that are easy to do and fast to do to fail first. So the thing is that it's probably a better thing to do the as permission check after the URL check, because checking the URL is faster than doing all of these clones and all of these things. So we basically want to transform into this, so that we first check the URL, and if it doesn't, and if it matches, then we check if we have the permission to do that. So it should result in a faster API. So yeah, this is a very easy change. I just wanted to showcase that because the way the API is built, I think is very nice. It uses VARP, and VARP works with filters. So you basically do combinations of filters with ANDs or ORs. Yeah, so I'm going to quickly do that with all of the APIs. Basically putting everything after ANDs. Alright. Alright, feel free to ask questions because this is probably going to take like a minute. Alright, nearly done. We have 3 or 4 more. Alright, that was the last one. No, there is one more. Alright. And that's it. Alright, so yeah, that was a little change, but it can definitely have an influence if you have a lot of incoming requests. So now, basically, just to sum up, we are only checking the permissions when we already checked the API URL, so that we are not without the change. What it would have mean is that for a single request, we would have checked the permission for all endpoints, which is obviously not what you want. Cool. Alright, so I guess I can push that. How do I call that? Dispatching. Alright, first task done. Alright, so that was this one. Then what do we want to do now? Let's do the alright, let's maybe start with the parents thing. This happens in another branch. I don't remember the name. That's use parents type. Alright, this one is interesting. Basically, what happens is that, let me get the type. We tried many things regarding this. Alright, so if you follow the development of IOTA, you know that recently we changed the number of parents from 2 to 1 to 8. So now a message is allowed to reference 1 to 8 parents instead of 2 previously. What we wanted to do at the same time is to have strong guarantees regarding the number of messages you reference. the usual thing in Rust is that you try to encode as many things as part of the type system so that it's checked at compile time and not as runtime. So as much things as you can make the compiler check for you, you do. So by doing this, we saw the opportunity to add some checks at compile time. Basically, the minimum number of messages is 1. So we wanted to encode this as part of the type system to avoid having a runtime check that says 1. So that it's virtually impossible to create a message that references 0 messages. In practice, it makes it a bit more complex, and it turns out that you still have to have this runtime check because it's part of the protocol that the number of messages is encoded into the message serialization. So you definitely have to have this check. So if the check is there, then there is less incentive to actually have this as part of the type system. So the previous idea was to have one message as part of the struct and the remaining messages as part of a vector. And that would have made it virtually impossible to create a message with 0 parents because it's part of the type system that you have 1. So this was just an attempt. It turns out that it makes it a bit more complex. It doesn't give that much. So I'm going to switch back to having a vector, but we keep this new parents type. This is still nice to have a new type for the parents because the parents are shared between messages and milestone payload. So we have this. We have the message that has parents, and you have payload, milestone. Is it part of the essence? Yeah. And you also have a parents type here. So instead of having the runtime check at 2 different places, we want the runtime check to be in a single position so that you don't have too many risk of failing this runtime check. Alright, so I am going to kill this one, rename this to, let's first do something. I haven't compiled in this branch for a long time. Why cap it at 8? I mean, this is a good question. You have to cap it at some point. There were some simulations and research, and it turns out it should be less than 8. If you go, I think this was being discussed in Discord in the Tango Math channels. So if you want some more information, like very detailed information, that's where you should go. I'm going to write the channel somewhere. Alright, so something is not compiling. Alright, so a recent change that I did is to have Serde, which is the serialization and deserialization library we are using. We made it optional recently because that's not something that is absolutely mandatory, but this wasn't changed for parents. Basically, you have this syntax in Rust that allows you to optionally compile things. So as you can see at the moment, I am deriving deserialize and serialize for this struct all the time. So it means that this is mandatory. By doing it this way, you only derive serialize and deserialize if you have the Serde feature. So like that. And this is something that you configure in your cargo.toml file. And you can see that Serde is optional. Alright, so let's see where we are now. Why is it taking long? Alright, it's compiling. Let's see the example, the cargo test. Oh no. Alright, anyway, we can probably start changing that. So I'm going to remove the first. I'm going to change the name of that to inner. Then we kill this. Inner. There is no need for the +1 anymore. What is this? Right. Alright, so now that's just that, self-inner. What do we have here? Alright, alright, that's good. We don't have the first anymore. We don't need -1. And we don't have that. Alright, so that looks good. Now, alright, so what's important is you can see is there. We have the runtime check. And that's where you need to be extra careful. So now we have it in only one place instead of having it in both the milestone payload and the message. So this is a nice thing to have. Alright, so this was compiling while I did the change. And now an interesting Rust trait, which is DRF. So what we did here, alright, I'm going to, now we only have one field, so I'm going to do something different. I'm just going to do a struct like that. Alright. When you do struct like that, you have a named field, so fields we know without names, but they are numbered, so you can call it 0. When you have only one field, usually you do that kind of stuff. Alright. So this is what we call a wrapper type. We just do a safe abstraction of something that is not really safe. Just handling a vector in itself would not be safe for our use case because vectors can have any kind of size. So if we were just handling a vector, there would be no verification that the size of it is between 1 and 8. By having a parent type, the only way to create a parent type is to go through the new method, and this new method provides a check. So it's literally impossible to create a parent type that is invalid. So when you are manipulating a parent type, you know that it's valid. So you know that it's between 1 and 8 parents. So it's just a safe wrapper of a vector. Alright, we have some errors there. What's happening? The thread serialize is not implemented. So Tango metadata. Let's see what it says. Tango. Alright, so basically this is another crate, Bitango, and it needs serialize. It needs serialize on the milestone index, which is defined on the message crate, and we just said that Serde is now a feature. So my guess is that the feature is not requested in this crate. So let's see. Yes. So we are basically using bmessage, but we are not requesting the feature Serde of this. So we just need to tell it that we want to use Serde feature. So we do something like this. If we do the previous version, tells that the Tango Crate is using the bmessage crate with no features at all. So the bare minimum. But we need, for this crate, we need bmessage with the serialization feature. So we tell it. And this should compile. I mean, this part should compile now, but we broke something, I guess. All right. So now we only have one parameter, and we had two previously. So I guess some stuff is breaking. SRC brand, parents. All right. So we just removed the first parameter, and now it's 1, not 0, to equal 8. Maybe I can say something about that, because that's interesting. This syntax is a special Rust syntax that is going to create a type that is called range. So this is going to create something like that. When you do ... it's going to take this and consider that's the start of the range and this is the end of the range. And internally this is going to create a type that looks like that. Alright, so this is going to create that internally. Y7, the start is inclusive, but the end is exclusive. So this is going to create that. If we change it to this is another syntax. It's going to create another type that is called range inclusive, and the end would be inclusive. So this is going to create that. So basically we have two ways here. Either we do that, so 0.9 or 0.8. I do have a preference for 0.8. And this was 0 to 8 because we had a static parent, but now we don't have one, so it has to be 1. Alright. Oh. Ah, alright. Well, that's a bit annoying because this function needs a range. Alright, well, I don't have any choice here there. This needs a range, so I have to give it a range and not a range inclusive. So I have to say 1, 9. Alright, let's see where we are now. Good. Test parents. Alright, now the tests are failing, which is probably a good thing. Tests and parents. Alright, so it's all for the same reason that we don't have a static peer anymore. So we don't have this. Alright, I'm going to inner and message IDs. This would be 8. Let's quickly check, we don't have this anymore. want to go from 1 to 9. Alright, let's see what it says. Alright, that's another test now. Alright, I guess we can do something like that. No? Alright, this is in a test, so I'm kinda allowed to do unwrap. I would not do that if it was not a test. Because basically if the unwrap fail, it's going to make the test fail, so something bad happens anyway. So unwrapping in test is fine. Parents new, and unwrap that. Alright, that was a pretty bad idea. I am compiling the tests in debug mode, so the proof of work test is going to take ages. What can I do? Yeah, I have to compile in release mode. Yeah, doing proof of work in debug mode is a bad idea because under the hood it uses curl, and curl in debug mode is really bad. So it would probably be faster to recompile everything in release mode and to do the test in release mode. In the meantime, I am going to explain this one. This threat is interesting when you are doing wrapper types because it gives you access to the inner type. So let's get back to parents. Basically, now that we have a parents type, it ensures that the inner vector is valid. It can't be in an invalid state, so it can't be 0, it can't be empty, and it can't be more than 8 parents. But in most cases, it's not very handy to manipulate a parent type because you have a lot of nice features in a vector. You have a lot of methods that are already implemented on vector that we are lacking on parents. So something that we usually do when we have wrapper type is to implement deref so that we can get back access from to the vector. And this is not done in a mutable way. So you can get access to the vector, but you are not allowed to modify it. So you can't remove parents, you can't add parents. This would have been possible with another threat that is called derefmut. If you do derefmut, you get access to the inner thing and you can modify it. But we are definitely not interested in this one because it would basically break the promise we are doing that the vector is in a valid state. So we are not implementing derefmut, but we are implementing deref. It works like that. Oh, we have a failing test. We'll see that later. Alright, so let me show you. Alright, so impl deref for parents. The target is what you want to deref to. So what we want to deref to is the inner type. So this is the vector of messages. And deref is in ops as well, I think. And this is self 0. Alright. So now we have an easy access to deref, to the inner value. Sorry. So basically what it means is that let parents equal parent new. Alright, deref is a threat that is called when you do something like that. So when you put a star before a variable, if it implements deref, you would get the target type. So basically this is you would do something like that. So you would get access to the vector if you do something like that. So this is very handy. Alright, so we have failing tests. What's happening? Invalid parents count. Uh, 23. Alright, so this is failing. Wait, what? Wait, what was this test supposed to be? Because visibly I broke it. Alright, so it was new invalid more than max. So basically we are looping 8 times. So this should always. Oh, alright. We have to add one. Alright, because we had a static one before, so inner should already come with something inside. So instead of doing that, I'm going to do that. So inner already contains 1. Then we loop 7 times and it should be fine, and then this should fail. So let's see. This was before, we have 2 fails, and it should pass now. Alright, so we have only 1 fail now. Which one? 37. This. Pack and pack valid, so we are trying the serialization. Why is it failing? So we are creating a parents with 8 parents, so this is fine. Then we are packing that, unpacking, and it fails. Well, that's interesting, because it says it has 9. Alright, so maybe... Alright, so I see a first mistake here. I forgot to remove this +1, which was the static peer. I am not sure that was the mistake though. I mean, let's see, maybe it was. Ah, alright, no, the mistake is there. Because I am doing a range and not inclusive. So we basically read, this is the deserialization by the way. So we have a bunch of bytes. It contains the number of parents. We get the number of parents here, we check that it's right, but then we loop in a range manner and not inclusive range. So we basically have 1 parents of difference. So either I do that or I do +1. but as I said, I prefer this. Wait, was it? No, the test was successing now. Why? That's interesting. Alright, well, alright, so this was actually the mistake. And now I made it fail. Yeah. Alright, my bad. I removed what I just said. We are basically using this method and we are writing it. So there was a +1. I removed it and that was actually the issue because we are writing it there. I am not sure this method is needed anymore. Anyway, let's keep it. Alright, but you see the importance of tests. Because I messed up at some point, I forgot to remove this +1 and the test was failing because of that. So very important to have a lot of tests. Anyway, now everything is working as expected, and let's see if everything works in the whole code base because this is being used now. Parents. Alright, what time is it? Alright, I'm going to keep this one for later because we did the most interesting thing. Now this is just making the API to fit with the new type, so this is not really interesting for you to show. So I'm going to commit that, remove first static here, and we are going to switch to something else. Alright, what did we have now? There. Alright, so we almost finished this. Alright, we have this one. Let's do that. How do I show this? Explorer, IOTA. Alright. Alright, you may know that we changed the address format, of course, because we removed ternary in Chrysalis part 2, so it basically changed the format of addresses. If I show you, we have this RFC that is called bake32 address format. Alright, so we have this format which is called bake32. It comes from Bitcoin, if I'm not mistaken. There was an RFC on their repository to introduce this, but this is a handy way to encode many different address formats in just one. So it looks like this, and the thing is that our protocol supports the addition of new address formats in the future. At the moment we are only using ED25519 addresses, but we can assume that more address formats are going to come in the future. And this bake32 format is a way to encode all of the different potential address formats into one. Which API does give you a swagger? That's a good question. I didn't write this RFC, so I don't remember the name of this. Let me check. Where is this? REST. I think this is Open API something. Yeah, I can't really give you an answer to that. So maybe you can contact Sam on Discord if you want to answer. I'm not sure what tool was used, if that was your question. Yeah, I'm not sure about that. Alright, so this Bake32, you can see that at the moment it only supports ED25, and there is a byte to tell what kind of address is supported. 0 is for ED25519, and then you have the ED25519 bytes. Alright, but as you can see in the Explorer, maybe I can do something like that. With the Explorer, can I do that? Yes. Alright, you can see that the Explorer works with two kinds of addresses. You can give it Bake32 addresses, but you can also give it hexadecimal addresses. And that's also how the API works. So you can, it accepts both formats. So I can use the Bake32 address and I get back to this. I can also copy paste the hexadecimal address and I also get back to this. So when I was doing some tests, I felt the need to have a quick way to switch between the two formats. So I thought it would be a nice idea to have a tool, a node tool to convert an hexadecimal address to a Bake32 address and vice versa. So I'll try to do that. I have like 10 minutes. Alright, let's see. Let's switch back to the Chrysalis branch. Alright, so this is a tool, so this happens in the node. I'm going to create a new tool, so I just copy paste an existing one. I'm going to call it Bake32. Going to register the tool Bake32. Alright, let's remove everything. Let's do some renaming. Bake32. Alright, so now we should have the bare minimum to have a Bake32 tool. Let's actually put it in the tools. Bake32 addresses conversions, something like that. Alright, and then oops. Alright, and we register a new error type. Alright, what this should do, if we go to the node, let's do something like that. Now we should have registered a new tool. So if I use the H flag, which is the help flag, it should tell us that a tool is available. So let's see what I messed up. Bake32. Alright, yeah, I am not returning anything at the moment. Alright, so this is linking. In the meantime, let's think about how it's going to work. basically we want to accept both sides of the conversion, so from and to. So let's see how it's done in another one. Alright, let's do something like that. Basically, this struct up is the way that we are building the CLI. Alright, this is a bit slow, but I would like to show that. Come on. Anyway, so you'll see that by adding this type, I am adding a new verb to the CLI. So I am adding the bake32 verb to the CLI, and by nesting some types, I can nest some verbs. So now I could do something like that, from and to, and I would have from and to features. Alright, this is taking ages. Anyway, from and to, how are we going to do that? From and to, let me think. To bake32, from bake32. Alright. If you are converting from bake32, you just need to have access to a string, because you have the bake32 and then you are going to output something from it. It's a little bit more challenging if you are converting to, because if you are converting to bake32, you need to have a first type. So what you would have at the beginning is an hexadecimal string, but it could be any kind of address. At the moment, it's not really an issue because we only support ED25. But if we supported many different address types, we would also have to somehow pass the type, because ED2519 is not the only address that is hexadecimal and 32 chars. So we would not have any way to know what kind of type it is. But for now it's going to be fine. Alright, so finally we see that we have a new subcommand, and I can use it like that. Alright, yeah, of course, it's recompiling. Wait, how does that work? Yeah. Yeah, you have to recompile them. Anyway, while this is compiling, what I'm going to do is to match over R2 to know what kind of operation we want to do. So it's either a from, address, and we do something, or it's a to. What's wrong there? Expected expression. Do I really have to do something like that? Why is it complaining? Well, that's interesting. Alright, it's already 6 p.m. but I started 5 minutes left, 5 minutes late. So let's see. But I am not sure why it's complaining, to be honest. Yeah, I know. Alright, I don't remember what I did wrong in the previous one. Anyway. Alright. Now what we want to do is I will go to the message crate, look at the address type, transaction, output, address, there. And we have this try from base32. So I'm going to do that. Address, try from base32 of the address. Is this a string? Yes, something like that. I am going to unwrap for now. Alright, we need the address type. Use the message payload transaction output. Oops. Address. Let's base32 equal to that, and let's print it. Private module. Alright. Sure. Alright, let's do this one. Alright, it's going to take a little bit to compile, so I'll take any questions if you have in the meantime. This is probably going to take 30 seconds, and if there are no questions, that will probably be the end of the stream. Yeah, obviously I didn't have time to do this one, but it's a very minor issue anyway. So yeah, if you have any questions, feel free. Alright, so now you can see that if I just use bake32, it tells us that there are two subcommands. There is from and there is to. So we just implemented from now. So I use from, and if I do that, it should tell us that from needs an address. You can see that it's very nice the way this CLI is being constructed, because if I do something wrong, it tells us exactly what should happen. So now it tells me that from needs an address parameter. So I am going to use this. Alright, and pass it there. And something bad happened, obviously. Well, that's to happen during a live stream, right? Oh no, I messed up. Sorry. I took an hexadecimal address instead of the bake32, but I'm doing the from. Alright, so I give the bake32 address, and it says that it's an ED25519 address, and the address is this one. That's EFDC, and and you can see that it is indeed EFDC one address. So this is working as expected. So yeah, we haven't had time to do the two, but I'll do right after the stream, and you can see it on the repository. But it should be pretty straightforward as well. Alright, so nothing we did today was really hard. That was quite a low Rust level. So I hope you enjoyed, and maybe I'll stay 30 more seconds if you have any more questions. Otherwise, thank you very much for joining, and we'll see you next week for another episode. Alright, no questions, so thank you very much, and see you next week.